Calculating trigonometric values for points that are not on the unit circle. So this is actually a review from the grade 11 trig unit, except now that we're just going to apply the reciprocal trig ratios to it. So we'll start with that. So in example 1, you have the point -5, -12. So this is an x and y axis. It would go this way and this way. So I kind of exaggerated quadrant 3. We can see this is in quadrant 3. Lies on the terminal arm of an angle in standard position. What is the value of each trigonometric ratio? So we know it's a point down here, so I'm just going to estimate -5 being this distance. -12 is going to be further down here. So I'll put a point. I'll try and line that up there. And we know it goes through the origin. And we don't necessarily need the entire angle in standard position. Standard position means the angle would go all the way around here. What we need to do is look at the reference angle. The reference angle is always the angle to the nearest x-axis. So we're going to put this and draw my right angle here. So this is the reference angle. We'll just put an angle symbol in here that we'll be looking at. So looking at this is a distance of 12, or if you want to put -12 in, keep the signs there. And then this is a distance of -5. So we want to find sine theta, which is opposite over hypotenuse. So we need to find the hypotenuse. To find the hypotenuse, we're going to use Pythagoras theory. So you want to show your work. You don't have to write out the formula for this. So c squared is equal to -12 squared plus -5 squared. Make sure there are brackets around there because of the negative signs. And then you're going to evaluate this. So c is equal to 13. Now, this happened to be a perfect square. A lot of times this will not work out to be a perfect square. So you leave your answer as a radical. You may have to simplify it, but we want exact values. So I'm sure that's going to happen in some of your questions. All right, so now we have this, so we're just going to go opposite over hypotenuse. So -12 over 13. Cos theta is adjacent over hypotenuse, so -5 over 13. Tan theta is opposite over adjacent, so -12 over -5, which you want to simplify the signs to +12 over 5. Note that the cast rule still applies when we use these signs. Cos and sine are negative in quadrant 3 and tan is positive. So what's new is now the reciprocal trig ratio. So the reciprocal of sine theta is the cosecant theta. So cosecant theta is equal to the reciprocal of -12/13. It's still -13 over 12. So the cast rule still applies the same as it would to the reciprocal functions. Cos theta is secant theta is equal to, so the reciprocal, so keeping it -13 over 5. And then cotan theta would be the reciprocal of 12 over 5, so 5 over 12. So this part is sort of the new part. Now we're going to look at part B as well, because it goes with this question here. Determine the corresponding point P theta on the unit circle. So if this point, so I'm just going to draw the ordered pair here again, or sorry, the point and the ordered pair, -5, -12 through here. So this is the point -5, -12 right here. I'll draw that triangle again, not that we really need it, but it's just nice to sort of compare the two diagrams. So we have that. So this goes way out to -5 and -12. A unit circle, remember, only goes a distance of 1 unit. So I'm going to draw a small circle here. This only goes to a distance of 1. This would be where -1. So this question is asking, what is this point? Well, this point turns out to be the cos theta value is the x and the sine theta. So your point theta is asking you the x and y. So it ends up being cos theta, sine theta. So of course it's a fraction. It's got to be a number less than between -1 and 1. So you're just going to take these 2 points and write them as an ordered pair. So this is sort of the grade 11 step. Applying it to grade 12, we're going to be talking about points on the unit circle.